Okay, I hope all of you see and hear me well. Okay.
Very good, good.
Okay, so I'm Irene Poza, and a researcher at the Research Group Architecture and Energy of the University of Valladolid. And today I'm going to show you a study that we carried out last year in collaboration with Universidade do Porto. And we will try to give an overview of residential building airtightness frameworks. It's a review. And as you can see here, the review encompasses the importance of databases, normative airtightness framework, whole building and analysis of whole building airtightness databases, focusing on their structure, measurement, data acquisition, and then we analyzed after gathering all the details. We identified the strengths, weaknesses, opportunity, and threats, and then I will finish with some conclusions. So we worked on a review on the main airtightness databases and setups in Europe and North America, motivated by the growing interest for airtightness, the fast spread of regulatory frameworks, and as you can see, also the stricter requirements, schemes for testing and quality control, and the creation of fast-growing airtightness databases that the other presenters just presented. So we thought that analyzing the whole picture would give us some keys and opportunities to learn from good practices and to avoid mistakes. And therefore, it could be a good starting point for countries where airtightness is not a priority, but are not aware of the issue, like that was our case, Spain and Portugal. And maybe it could be also, it could serve as an evaluation tool for the improvement of the existing databases. So we checked all the available literature, the regulations, and contacted several experts. Maybe some of you are present here right now. And finally concluded the study at the end of 2019. So any update until for the past year has not been is not here, but there have been a lot of updates since regulations on this issue are experiences fast changes. So our objectives were to explore the main airtightness databases based on the data available, their input scheme, their purpose, the analysis of the data gathered, and the overall structure and requirements. And then we compared those databases, finding the differences, identifying gaps, and then identifying also strengths, weaknesses, problems, and opportunities for future actions. So first of all, our question was why are airtightness databases of a built stock useful? And we identified several purposes that are shown on the slide. And for instance, they are very useful, and the most immediate use could be to demonstrate compliance with regulations. But they are also very useful to get information for modeling and designing, for instance, or to visualize trends. And that's what we try to do. So airtightness databases are storages of potential knowledge, and they can be identified also as tools to analyze the built stock. So first of all, we considered that addressing normative legislation was key to frame the subject, and also because their criteria and nature are closely related to how and why the current schemes are implemented the way they are. So we have, on the one hand, Europe, where the focus for the past few years has been to build nearly zero energy buildings, motivated by Energy Performance Building Directive. So to control the impact of air leak or of air infiltration, it's key to control air tightness. And but European directives don't establish specific requirements. So these practices control is managed different in each country. You could also see in the other presentations that there are some differences. And on the other hand, North America, the issue is similar, since air tightness requirements get enforced by state governments. And here in the table, we compiled the regulatory air tightness approach of a great number of European and North American countries in terms of here you can see the metric used, air permeability limits, and also whether on-site testing is mandatory or not. First, the regulatory approach is somehow different depending on the country, as you can see in green. Some countries and the most representative approach is to have air tightness mandatory values, but there are other approaches, like in Poland, where air tightness is recommended, or Belgium, the Flemish part, on Canada, for example, where there are just default values, and there are still some countries where no consideration has been done to air tightness so far. So regarding measurement metrics, in the second column, we can see that parameters are derived from the airflow rate at established pressure difference, that it's usually 50 pascals. And this airflow is normalized by the internal volume, and that is the N50, the envelope area, which is Q50, and rarely net floor area, W50, in the cases of, for example, Netherlands and Denmark. And France also differs regarding the pressure difference, because they show that they express the results at pressure difference of 4 pascals, like Adeline just stated. And I heard Barry saying that they use AP50, so that might be a change we should do here. So additionally, regulations on air tightness establish different criteria on limits definition. This is the fourth column, and these different criteria are based on different things. For example, the integrated ventilation system type. For example, in Germany, we have different requirements depending on if the dwelling has natural ventilation or mechanical ventilation. And also other countries have integrated and add heat recovery systems. For example, there are also other criteria like dwelling typology, such as the case of France, neo-retrofitted dwellings, the energy performance label. For example, in the USA, the criteria is the climate zone. And in Denmark, ranges between different geometric properties, or the case of Canada, where the criteria is based on the prescriptive path on air barrier detailing. And finally, focusing on the need to perform an air tightness test, we can see that only some countries like the UK, Ireland, and France need to perform an air tightness test, and to comply with to prove compliance. But the vast majority of the countries do not ask for an air tightness test, and they usually just estimate the air tightness based on building characteristics. So as you can see, overall, there are great dissimilarities between each country, between the approaches of the countries. And focusing on Europe, here you can see the trend that is of more awareness in countries with colder climate conditions, except for most countries in Eastern Europe. And on the other hand, in Mediterranean countries with milder climates, this building airtightness has still not been the focus, but we expect changes in the near future in countries where this issue has been ignored until now. So let's focus now on some airtightness databases that have been analyzed, focusing on their basic functioning, setting criteria, and aspects to consider. For example, regarding the structure, several aspects can be analyzed. The first thing that we highlight is the fact that databases are usually managed by regulatory bodies or recognized associations or companies that are in charge of its maintenance and management. The figures regarding the size are for sure outdated already. We heard Barry talking about 875,000 tests and Adeline 380,000 tests until 2008. So this can allow us to see the fast trend in countries where testing has become mandatory. And it is also worth mentioning the case of the Flemish region in Belgium that Martin explained, where testing is not mandatory, but these disadvantageous default values for airtightness in an energy performance calculation make it implicitly mandatory, and that's a reason for those figures too. And well, regarding the state and updates, we can summarize that datasets in countries with airtightness regulations, and especially with mandatory testing, favor the active updates, whereas it's difficult to keep ongoing datasets in case of one-time efforts. Another challenge is the gathering data with uniform criteria when multiple agents contribute to its growing. For that reason, datasets need to comply with specific requirements and protocols, and therefore several databases include quality control processes, as you have also seen. And finally, I will just comment on the information and the form of the data gathered, which isn't here in the table. But I would just comment that most of the study databases save the information required by the international standard ISO 9972. But in some cases, further data gets required by national regulations. We saw the case of France with analytics paths register, and this information might be really useful. And it also must be highlighted that complete and accurate information of the dataset, including not only test results, but also characterization and other complementary data allows for subsequent data analysis and the study of trends. Now I will shortly give an overview of the measurement protocols. I will be very short, but you can see that in European countries there is a typical measurement framework based on ISO 9972. Although the measurement methods adopted in each country differ with, for example, additional instructions regarding methodology, building preparation with different protocols for sealing also, and building dimension assessment. So we must highlight that this compromises properly the proper characterization and also the comparison. And through several SWOT schemes, we try to analyze and summarize the strengths, weaknesses, opportunity, and threats of the analyzed databases and the different approaches. And the first one is the regulatory approach. And from this point of view, the weaknesses are mainly related to the adoption of different metrics and reference pressures among countries. And on the contrary, the performance limits based on a combination of several variables and common criteria for limits establishment would constitute an opportunity for us. Concerning the database's structure, common trends have been identified. Recent initiatives in European countries seem to constitute examples of good practices that could be the basis for further initiatives, whereas the main weaknesses detected are related to the lack of data in some regions and the representativeness of the whole building stock. In any case, a common framework would constitute a powerful tool for easy data analysis and control. And regarding the measurement data acquisition, the weaknesses are related to the diverse procedures established in the measurement protocols. So a path for uniformization on the use of the most promising validated methods of different protocols should be pursued, and also a convergence between North American and European protocols would open significant possibilities for comparison of the results. So finally, it can be said that a trend of increasingly strict requirements is observed with the objective of reaching nearly zero energy buildings in Europe. And although proven compliance is only required in a reduced number of countries, other ones are expected to join this trend in the near future. And also, among other relevant remarks and discussions, it is concluded that the lack of uniformization in methods between countries, the need for minimum data, and implemented setups are some of the main issues to address in future approaches. So we believe that a common framework proposal should be based on a user-friendly, accessible web-based platform for data communication between the different agents to apply unambiguous and qualitative measurement procedures regarding above all building preparation, data acquisition, and the presentation of the results, and a comprehensive data gathering of dwelling information and visual inspection, and consideration of applying qualitative tests to locate leakages such as thermography or smoke traces, as Martin previously mentioned, and also Adeline in the French approach. And lastly, an implementation of quality management schemes, including procedures for tester training and results control. So the study resulted in a paper published in the journal Building and Environment, and I invite all the participants in this webinar to have a closer look at it because it contains further information, and of course your feedback is very welcome to make us improve this review. And well, this is all the reference we used, and that's all from my side. Thank you very much.